Hello, my name is Brooke Williford, and I'm going to be discussing my LabVIEW program for homework 2 in electronic instrumentation. So on my screen, I have the block diagram of my main VI. I have a while loop, so that way it continuously updates over time. And I used a shift register to store and update the time variable. So the time value starts at 0 and is increased by 1 each loop iteration. And that time value is used to generate the input signals, which are the first one is M1, and I used the division block to multiply pi over 4 times sine. So I have M1 equals sine of pi over 4t, and I have a wire between my shift register and my multiplication block to multiply that t value that updates over time. So same idea for M2. Except it's pi over 11 and it's cosine pi over 11t. And then for M3, I use a product block to multiply M1 and M2. So each signal is sent to its own waveform chart that is displayed on the front panel that I'll show later. And each of these signals can be viewed in real time with that waveform chart, with those waveform charts. So for calculating Z and Y, or the um, average and RMS values, I used a sub VI. So clicking into my sub VI, I have the front panel, which contains X1, X2, X3, the input and the output. And then for that, I have the block diagram for that. And I used a K structure here. So that way the K structure will determine whether to run the average, to calculate the average, or to calculate the RMS value. So this is the average case, and as you can see, I've just added X1, X2, and X3 together, and then I divided them by 3. That's sent to the output. And then for the other case, the RMS case, I use the RMS formula by squaring each of them, and then adding all of those together, dividing that by 3, and then taking the square root of all of that. That's sent to the output. So I used this sub VI in 2 different instances, one for calculating Z and one for calculating Y. Both of these are connected to M1, or X1 is connected to M1, M2 is connected to X2, and M3 is connected to X3 in the block diagram for both Z and Y. So I also have a stop button to stop the while loop if necessary or if desired. Now moving on to the front panel, I have all of my waveform charts for M1, M2, M3, Y, and Z. So these will display all of the results for each continuously as the program runs. So I'm going to show that now. I'm going to run the program. As you can see, it runs until I click stop. So overall, It demonstrates how like LabVIEW can be used to generate time-based signals. They can be processed using a sub-VI, and then the results can be displayed continuously in real time. And that's all. Thank you.